All right, calculus. We're in still in 6.1, just the second part of this. And really what we're going to do is we're going to find an original function for f of x, which I'm finally going to explain why when we have the second derivative here is 2, why we have a couple things. First of all, what we want to do is establish that the second derivative of x dx is equal to f prime of x with this plus c in here. So a couple things too that I wanted to mention. The reason why we have that dx right there is to let you know that it's a differentiable function, which essentially, like, you may have recognized, I'm going to erase this here soon, like y equals, because I've had some students do this. Think about how y equals, what would it be, 2x? And then they would think about, okay, well then dy dx is equal to 2. But the issue that we have is, what if we had like plus, I don't know, plus 8 right here, just making up a number. Well, the derivative of y equals 2x is 2, and the derivative of 8 is 0. But the issue then is what do you mean dy dx? And that whole premise is that, well, I could multiply, it's not really true, but it helps students understand that you can multiply dx over here, which is why there's a dx in the problem. So like I said, I'm going to erase this because this is not really, I just wanted to quickly mention why we put the dx there. So the whole point of this is the antiderivative of 2 dx is equal to the first derivative, which is what we're going to find. Well, as we add 1 to our exponent, it's x to the first, so you don't have to write to the first, and 2 divided by your new exponent, 2 divided by 1 is just 2 plus c. Now this is the equation that we have for the first derivative. So f prime of x is equal to 2x plus c. Now this is called an initial condition, because now we can use this to figure out what c is. So when x is 2, 2 times 2 plus c, and needs to equal 5. Well, 2 times 2 is 4, so as I subtract 4 over, that tells me that c must be 1. So now what we've just established is that the equation of f prime of x is equal to 2x, but now we can replace c with 1. So I was super far off earlier when I guessed 8. But now what we can do is we can find the antiderivative of that, and that will find me the original function. So that tells me that f of x will equal, remember, you add 1 to your exponent, divide by your new exponent. Well, 2 divided by 2 is 1, which is probably why we have it, plus add 1 to your exponent, x to the first, and 1 divided by 1 is 1. No need to write it. But then another plus c, and then we use our last initial condition, that f of 2 equals 10. So what that tells me is that 2, when x is 2, we must equal 10. Well, 2 squared is 4, plus 2 is 6. Subtract 6 over, and that constant must be 4. So the original function is x squared plus x plus 4. I believe the directions also wanted you to solve this. But if you got this one right, then you had to have gotten the first derivative correct and go on from there. So I think I'll show a little bit less work on number 2, just because I think it's pretty straightforward that, you know, you're doing the antiderivative of this to find f prime of x. So add 1 to the exponent. Now I'm not going to divide by the new exponent. I like to multiply by the reciprocal, and then plus the constant. So now I can establish, based off of this, f prime of 4 equals 2. I'll even write that out, f prime of 4. You're plugging 4 in for x. Now remember, to the 1/2 power means a square root which is 2, but the negative we'll put into the denominator. So negative 2 over 2 is negative 1, plus c must give you a y value of 2. So as I add 1 over, c must equal 3. So that tells me that f prime of x, and if you want, you can rewrite as negative 2 over root x. Doesn't bother me at all. Plus 3. Oops, that was a terrible box. But it's definitely worth, keeping it this way, because then when you do the second antiderivative to find f of x, it makes a little bit more sense to add 1 to that exponent, so it's 1/2. Looking up here. And then instead of dividing by 2, I would multiply by the reciprocal. Well, negative 2 times 2 would be negative 4. The antiderivative of 3 would be 3x. And then plus that c. And that should make sense because the derivative of 3x is 3, and the derivative of this is that. And then use this last initial condition. Well, that's kind of nice because anything times 0 is 0, and the square root of 0 is 0, plus 0. So c must be 0 in order to equal 0. So that tells me that f of x is just that piece. And I would rewrite it as negative 4 root x plus 3x. If you don't believe me, you're welcome to work through it. Otherwise, I will share the answer key. You can see he shows a lot more work than what I did, which is fine. But I think you can evidently see that f prime of x is 2x plus 1 here, x squared plus x plus 4. I showed a little bit less work, but you can hit pause and watch it. And then you can see on this work over here, f prime of x was that, he even wrote it the way I did, negative 2 over root x plus 3. Once you figure out that c is 3, there it is. And then continue to work through to figure out the antiderivative of that one. So if you like his work more than mine, go ahead and hit pause. You can copy it, you can soak it in, you can do what you need to be successful. Now we just have a quick word problem here. And again, I like how calculus is written. It just makes a lot of sense to me. And by the way, I like the phrase a differential equation. Okay, so you'll get used to that. That means that this is the derivative of something. And I'm going to go back to my analysis before that dh. You can think of it this way, 1.5t plus 5. And then multiply that dt over. Not technically right, but it's doable. So if you think about doing the antiderivative of both sides, you're going to be left with, I think I can actually do this right here. I'm just going to show it right here because I'm sure I'm actually doing part B. Is dh on this side would just be h. Think about it as no variable right here. You can think of it as a 1, something like that. Well, if you add 1 to your exponent, it'd be h to the first, and then divide by that new exponent, just be 1h. And over here, I think it makes sense that you'd add to your exponent, divide by your new exponent. Well, it might actually make sense to write that as a 0.75 since it starts as a decimal, plus 5t plus c. You can verify that that's derivative is up there. So I'm going to reference this again later, and why it might make sense that this is the same thing as this. Okay, so part A. Well, pause the video. Make sure you understand what's going on in the problem. We're talking about the shrub is height, 6 years of growth and shaping. Here's the growth rate. It's a differential function. And notice that the seedlings are 12 centimeters tall when they're planted. So that's going to be important as well. So find the value of the differential equation when t equals 3. That's just plugging in 1.5 times 3 plus 5. Just use a calculator. 4.5 plus 5 is 9.5. Now it's a differential equation. And it even tells you that it's a rate, growth, there it is, rate. So that's based off the height is in centimeters, and I believe it's per year, where t is in years, so centimeters per year. Now, as far as context of the problem, I like to just reference the answer key. So exactly 3 years after planting, because it's a differential equation, it's the rate at that moment that the height of the shrub is increasing. And I kind of already did this next piece, although he didn't move that dt over. I don't know why that dt is there, but I already did that part. H of t is equal to 0.75 t squared plus 5t plus c. But we can figure out what the c is because I said it in passing. They're 12 centimeters when they're planted at t equals 0. So if we plugged in 0 here, well, 0 squared times whatever is still 0 plus c needs to equal 12. So that's your clue that h of t's equation should actually be that c needs to equal 12. Because if you were to plug in zeros for these t's, you'd be left with c is equal to 12. So c must be 12. So how tall are the shrubs when they're sold? Well, if you go back to the question, they say that they're sold 6 years afterwards. So I would interpret that as to say, okay, well, now we want to figure out what h of 6 is. And you can use a calculator, type it in. I'm going to trust this person's answer. 6 squared times 0.75 plus 5 times 6 plus 12 equals 69 centimeters. So definitely a two-parter to this. You want to make sure you have both of these answers. And then we have one more problem involving particle moving with a velocity, and at time t equals 1, its position is 4. So the first part, find out what's the acceleration. Well, the acceleration is still the derivative of velocity. So remember, velocity, this is the same as t to the negative 1/2 power. So acceleration, derivative of velocity. So bring that negative 1/2 in front. Subtract 1 from the exponent. So as I'm asked to find a of 9, that tells me, okay, well, the square root of 9 is 3, to the third power is 27. The negative is telling me to stick that 27 in the denominator. And 27 times 2 would be 54 if I did my math right. So maybe a little bit more work should be shown there. You can verify with the calculator, but I'm almost done with the notes, and I'm also almost, I guess I'm ready. Anyway, let's find the position. I like to use x of t because it's moving along the x-axis, or p of t, I believe, is in the notes that we use. So remember, you add 1 to the exponent, so t to the 1/2. And you multiply by the reciprocal, because we're doing the antiderivative to go from velocity to position as the antiderivative. And I'm running out of time, but I think you can understand it. But then there's this plus c. Since I ran out of time, what I'm going to do is just jump to this initial condition that I wrote x of 1 is equal to 4, but the person that did this did p of 1. So if you plug in 1 in for your t's, I think I had x's though, but whatever, and you were to do this, you would figure out that c equals 2. So here's your new equation, 2t to the 1/2 power plus 2. Now you can plug in 9. Well, 2 times the square root of 9 is 3. 2 times 3 is 6, plus the initial condition of c equals 2 gives you 8. Hopefully that makes sense. Otherwise, let me know.